Okay, good morning. Good morning. Welcome, welcome. I presume this is the first session of the day for you all. Yep. So my name is William Cho. I'm visiting from California. I'm responsible for the HP Aruba switching business unit. We're roughly about a 1,300 people organization where we develop the software, the ASICs, the hardware platforms that go into the Aruba CX switching portfolio. And so as Antonio had started the conference, yesterday's keynote, speaking about networking for AI and AI for networking, I'm going to try to provide a bit more detailed view around how to think about network architectures, systems as it relates to networking for AI, as well as some of the governance, the control, the sovereignty around AI solutions and workloads. And then we'll also have a bit of a demo. This is a future capability that'll be instantiated in our central platform. And here we're taking a lot of the AI ops for networking to get ahead of latency issues that might come about with a particular AI workload. And so we'll see a demo here towards the end of the discussion. We're a small group, so feel free to interject if there's any questions. We don't necessarily have to wait at the end. I have, 20 or so slides, so I think we'll have plenty of time. Okay, so there's a couple housekeeping slides. I'm going to touch on some future roadmap. So there's some disclaimers here, confidentiality, roadmap discussions, so on and so on. This is just standard housekeeping within HPE. Okay, so I presume many have heard of Gen AI, perhaps know what Gen AI is. Here's more of a textbook definition, if you will. But generally speaking, what we see a lot of in different market verticals, different geos, it's just the simple idea of being able to leverage artificial intelligence across a large data set and to be able to develop patterns, to develop structures out of that data set such that you can create new answers, new positions. Could be around text, could be around images, video, audio, and so on. And so this is the general concept of what is Gen AI. And so with that said, there are a number of key drivers. I have the luxury of talking to a number of customers, partners like yourself around the world. And I would generally summarize it as such. There are those that are trying to build core processes. How do I do more with less? So just within Aruba, as an example, we're leveraging large language models in our development processes. So if you think about bugs, so we have a very large development organization. We're using large language models to understand what are the different bugs, how do we track them, is there a bug that has been recently created that's related to a past bug, how do you correlate a series of bugs that might be related so that perhaps you can kill multiple birds with one stone. With our help desk as TAC, our TAC is developing large language models again, to help correlate and do an AI search against different cases that might affect different operators or customers like yourself. So those are just some examples of how you may leverage AI within core processes, again, to drive greater efficiency, greater acceleration of time to a particular solution without having to go through the human lift, if you will. And then there's the notion of improving customer experiences. There's any number of examples that can come about here. One is quite simply, being able to be in the healthcare industry and being able to identify root cause and be able to provide a better healthcare experiencing, leveraging AI technology. So you see a lot of these types of imaginative notions of how you can leverage large language model, a large pool of data, and be able to provide a more high fidelity, more accurate type of assessment or answer, whatever the question may be. And then the simple notion of disrupting or improving business models here, again, maybe using healthcare as an example. There's been the notion of developing gene sequencing for some time now, and so being able to leverage, again, large language models to understand gene sequencing and ultimately for drug discovery has helped a number of firms in terms of being able to accelerate the development of new drugs, being able to bring together different methodologies around testing and trial and error, which was formerly done a bit more manual, but having that history and being able to accelerate that experimentation process is where AI has helped a lot, especially in that healthcare industry. The next slide actually will show a bit more examples. Perhaps some of you come from these different market verticals. One of them actually is in the retail environment. In fact, we're working with a very large retailer, primarily US-based. In fact, I think they're entirely US-based. And so they are leveraging, interestingly, 4K cameras. So they have a pilot with, I would say, roughly 50 stores. They're a big box retailer. They have 4K, very high fidelity cameras. And so as it suggests here, loss prevention is actually one of the use cases. Loss prevention as well as inventory management. So they're using the cameras. It's all local inferencing, so there's no large language models. They're not building out large clusters in the store environment. It's in fact just inferencing. So based on an understanding of the item of interest, it could be a hammer, it could be a 2x4 piece of wood. They're able to actually identify and track inventory and also look at leakage. And so this is one of those kind of firms that, they do, let's say, $100 billion in revenue a year. If they're able to save 0.1% in shrinkage or loss prevention, this amounts to significant tens of millions of dollars given their size and magnitude. So perhaps some of you are in a similar industry where your business units are looking to leverage technology, whether it be around loss prevention, it could be around new drug discovery, it could be around oil discovery as another example. So there's any number of use cases. Again, I saw some number of hands where your firms are either exploring or perhaps already well down the path of building out large language models and looking to build training, tuning, and then ultimately inferencing out of those data lakes. So I wanted to shift gears here. That was really just a very brief backdrop, perhaps very rudimentary for many of you. But here within HPE, and Antonio had talked about this along with Fidelma yesterday at the keynote, it's not all about just leveraging the technology and looking to accelerate insights. It's also about how do you drive an ethical AI practice, for your firms? Actually within HPE, we have an organization that help drive these principles, these 5 core principles. And we also use that in a way to help guide our partners, our customers, to build an AI practice, with ethics, with responsibility, with inclusiveness, to be human focused. And so these are a number of key pillars that even our professional services organization has helped many entities like yourself to build out an AI solution that doesn't leave out certain sectors of your community, whether it be the partners or within your own employee base, to think about the human focus of AI such that we recognize the human aspect of the ethics and where AI perhaps could cross the line, but being able to do that with guardrails. Certainly reliability and robustness is another factor that you want your AI solution to be able to deliver on without, again, compromise. So this is just some of the key principles, again, that we look to indoctrinate in our own AI solutions. So we have a governance board. So any AI solution that comes either from the compute storage, GreenLake, or the networking organization, we have to actually propose what is the design, what is the outcome, what do we hope to accomplish with that AI solution, whether it be internal or as an external customer-facing solution. We present this to the governance board, and they will ensure that the design and the outcome will meet the spirit of these design principles. And so it's again something that we encourage many of our customers and partners to also think about, and it is a consulting aspect that HP provides. And further, HP is very active in a number of consortiums and standards. These are more US-based, in fairness. So just the simple idea of democratizing AI with the National Science Foundation. So the organization, HPE, is actually contributing and building out a shared research infrastructure. So not everyone has the investment, the fortitude, nor the skill set to go out and build an AI infrastructure environment, let alone having the skill set to build the software stack and so on. And so HPE is contributing back to the community so that there is an opportunity so that any number of enterprises where they don't have that budget or wherewithal can help build out solutions and pilot that with the NSF. Another one is NIST. NIST is the National Institute of Standards. And they're also looking at developing different measurements and methodologies to promote trustworthy AI and responsible use. Very similar to the principles that we talked about earlier. So again, just another example of how HP is contributing back to a community, trying to help foster and build responsible AI capabilities in what is very much a groundbreaking journey here for many of us. So when we think about AI, and I wanted to kind of provide a bit of a level set in terms of how we think about much of the deployment models as well as the quantization. Deployment is perhaps quite familiar. Quantization is simply kind of the sizing of the AI model, let's say in large to smaller scale. So when you think about deployment, it's quite simply, in the cloud, it could be on-premise or near-prem, and then certainly at the edge. It could be within a hospital, it could be at a retail environment, it could be at a colo for that matter. But training typically is done in very large cluster environments, so more likely in the cloud or on-premise at a private cloud. Tuning is a size smaller, and I actually have a table here that kind of give you a sizing in terabits of how you think about tuning as an application in between inference. And inference, can be quite large as a workload, but it can also be quite small. As I mentioned in that particular use case in the retail, inferencing is being done, at the edge with a couple petabytes of data simply from those video images that are being generated from those 4K cameras. And so much of that can be done at the edge. In many cases, that data could be time sensitive, or it could be with a very limited shelf life, meaning, after a few hours, the data is irrelevant, right? And so because of that latency and that time sensitivity, you want to be able to act on the AI and create those insights within the hour, within the day. Again, these are some of these things, just using that retail example again, where you might have shrinkage or inventory issues. You want to ensure that you don't have a stock out situation, at the edge. And that's where the inferencing and the time sensitivity of the data is important to having that application run out at the edge. Now, as operators, many of you are often challenged to think about the build-buy partner, right? So how do you think about your particular Gen AI workload? Should we look to design and build this out, ourselves? Is it something that we can partner or buy, as a service? And within HPE, you have all of the options under the sun. You can certainly look at a buy or partner approach using or leveraging GreenLake private cloud AI. Antonio had talked about this quite a bit and highlighted the announcement with NVIDIA that was done at Discover Las Vegas back in June. But much of this, you will have to often think about the different parameters that will help drive the decision criteria for your particular organization. So ultimately, depending on what your organization is trying to accomplish, there's going to be a business case, a use case for which you'll want to identify that will drive ultimately the investment level and the risk tolerance your organization is going to be interested in that make versus buy scenario. There's obviously the scale and complexity. You know, are you a large petroleum organization, a research institution where you may have tens, if not hundreds of terabytes of information or data? So these are all different dependencies that might drive the scale and complexity of your training model. Solution differentiation, data sovereignty are other examples. So many organizations, many countries have high compliance and regulatory requirements as it relates to data sovereignty. And so these are other factors to consider in your decision making. And then certainly training or inference, as we talked about. So the larger the data set, the more sensitivity you may have to that data as proprietary, but ultimately being able to build that on your own, hopefully with a higher ROI given that particular use case. So with that said, I'm going to go into a little bit more detail in the different solutions that HPE offers, both from a strategy as well as a technology standpoint. As I mentioned, I'm from HPE Aruba, so we offer a more, let's say, traditional mainstream Ethernet-based solution. There's also an offering called Slingshot. Have any of you heard of Slingshot or using Slingshot? Okay, a small number of you. So that's yet another alternative. It is a purpose-built technology that has built out really actually the top 3 supercomputers in the world. That was actually announced yesterday, again, by Antonio. But first and foremost, I did want to touch on, as a reminder, if you didn't catch it, at the keynote yesterday, we did announce a partnership with NVIDIA back in June. And the simple idea that we can offer a private cloud AI solution. This could be an as a service, could be on-premise, could be a GreenLake offering. And the whole idea is that we can provide the full turnkey environment. It's not just the infrastructure that could be a half a rack or up to multiple full rack solutions integrated with NVIDIA GPUs, HP compute storage, as well as networking. But it's also the professional services, it's the software stack. And we've actually built out a number of AI solutions. I have an example of a chatbot that we've built out with as Antonio Neri as an avatar. Perhaps some of you have seen that, but it's a fun project that we built out about a year ago and been demoing it at various events like this. But in any case, it is a full integrated solution set that HPE offers. And again, it can be provided as a service, either on-prem or as a private cloud offering within GreenLake. And so here, this is just an illustration of the different types of form factors, all with integrated GPUs. I'm going to show you one demo environment that actually has 16 NVIDIA GPUs. Just as an example. But again, this is a very exciting opportunity and one for which, if there's any interest, certainly feel free to reach out to your HP representative or partner, and we'd love to have a follow-on discussion with you. Now, as you look under the cover, and there are many different types of workloads when you think about AI that really span a very broad spectrum. So, off to the left, as I mentioned, the data set and the compute power and GPU power is going from least to the greatest, left to right. So AI inferencing, whether it be batch or real time, through deep learning, and then ultimately to very large scale generative AI, large language models. And so here you have a broad scale of infrastructure solutions with, let's say, less than 100 GPUs to hundreds, if not thousands of GPUs. And then from a fabric standpoint, what we're largely seeing are either Ethernet solutions, Slingshot, is an alternative to that as well. And then NVIDIA obviously has a InfiniBand solution. And we'll talk a little bit more about InfiniBand versus Ethernet. There's been a lot of discussion about this, and we largely believe that Ethernet is going to be the wave of the future. There's still a lot of work that needs to be done, but many, as an example, Meta or Facebook, they've already done some great successful production runs and have produced white papers on their Ethernet deployments in their Gen AI solutions to provide their integrated offering with their Facebook solution. And so here, this is more of a reference slide, so it'll be a leave behind that'll be available for the slides once they're available for download. But it just gives you an idea of the different characteristics of an AI model, whether it be the number of parameters, it could be less than 10,000, upwards of 40 billion parameters if you think about a large Gen AI model. If you think about the number of GPUs, again, there's the scenario where I mentioned it could be just one GPU in a retail environment. This one big box stores actually have one today, but they're looking to scale that to 2 to 4 per store. So that would be kind of the inferencing scale, if you will. But again, it could be going up to hundreds, if not thousands of GPUs in that Gen AI solution set. And then from a storage characteristic standpoint, there's the number of IOPS, the latency, and ultimately, it's all about maximizing the performance and the utilization of that GPU because it's such a large investment profile. And so everything follows in terms of the storage, the fabric, and being able to help drive and facilitate the calculations from the GPU cluster set. And so maybe I'll pause here. Is everything making sense? Are there any questions so far? No? Okay. Feel free to, again, pause or interrupt anytime. So from an AI architectural framework, perhaps many of you have seen this before. It gives you kind of a simple framework of how AI architectures are built out. So typically speaking, the front end is where you have general compute. It's typically Ethernet fabrics, and it's typically many to many in the sense that you may have many workloads, many databases, and it's general purpose. So this is your kind of general purpose data center environment. And so that's your front end fabric. You have the back end fabric that is largely putting together all of your GPU clusters, where it's largely, again, Ethernet fabric, and then you have the Gen AI fabric. Here, you typically will have very high performance dual paths. And so in that, if you can imagine in the middle there, the Gen AI fabric actually has two fabric paths. So typically you'll have the fabric within the server cluster that might house 4, 8, 16 GPUs, and it might typically be a PCI fabric within that server. And then you'll have the fabric that interconnects those servers and the racks. And so that's typically InfiniBand or could be Ethernet as we see more and more. So that's generally the way you'll have to think about the front end, the back end, and the Gen AI fabric, again, that might have an integrated, one example of that PCI fabric is NVLink from NVIDIA. Now, I did want to touch on how to think about Ethernet and InfiniBand. So any of you have InfiniBand clusters in your environment today? Okay, the gentleman that's also running an AI environment. So here, this has certainly been the tried and true fabric for HPC environments for many generations. But what we're here to generally express is that Ethernet is catching up quite significantly. And there's been a number of innovations that have been happening, certainly from a performance, bandwidth, latency perspective. And so many of you perhaps are familiar with the concept of Tomahawk 5. It's the latest 64 by 800 gig chipset from Broadcom. So Aruba, we also have a CX switch built on this Tomahawk 5. Again, it's literally 64 ports of 800 gig per port. This is really state of the art if you could think about a switch in a very small 2RU form factor. And so here you think about bandwidth and latency. This is where Ethernet is already surpassing InfiniBand from a bandwidth and latency perspective. And then if you think about it from a management, cost-effectivity, industry adoption, Ethernet is already ahead, right? If you think about the ecosystem for Ethernet, whether it be HP Aruba and all of our peers in the industry, silicon vendors, platform vendors, software vendors, it's just a much larger, like orders of magnitude larger than InfiniBand. And so from a cost and a multi-vendor, a dual vendor perspective, I don't think anyone is going to bet against the fact that Ethernet is going to win over time over InfiniBand. It's not necessarily prime time today, although Meta has proved that out today. And again, they've created a number of white papers where they've proven out the performance and the advantage and cost effectivity of Ethernet AI clusters over there. They have both InfiniBand and Ethernet. And this is all publicly available information. The one area that I will highlight is ease of use. So InfiniBand is a very closed architecture integrated with the NICs, with control plane, management plane, and so on. So it's a walled garden, if you will. And so you will find there are some number of benefits there. However, to complement this, anyone heard of the Ultra Ethernet Consortium, UEC? A couple of you. So UEC was actually founded by HPE, by the Cray team. I mentioned Slingshot as well. So there was some key technology that HPE ultimately is donating to the Ultra Ethernet Consortium. It is a consortium with all the key networking vendors, Cisco, Arista included, Juniper, the silicon vendors, the likes of Broadcom and Marvell, the cloud providers like Meta, Google, and Microsoft. So it is a fairly well-represented consortium, and the whole idea is to accelerate Ethernet to ultimately meet or surpass InfiniBand stack. And so you may see more and more in the press. Certainly if you would like to get involved, you can follow up with the UEC. There's a lot of work. HPE is a founding member. We're the lead steering committee member, but ultimately really trying to drive a lot of innovation. Everything from how you do routing. So there's a concept called cognitive routing or adaptive routing. The simple idea that you can packet spray any number of packets for a given flow on any number of lengths, so that orders and reorders in a way that you really maximize or minimize the latency across the lengths. So a lot of great work is happening. Again, HPE is at the forefront of many of these innovations. Okay, so I mentioned Slingshot, so a little bit of a plug for Slingshot here. Slingshot has been around for, I think, about 4 or 5 years now. This is not my area of forte, but we do work very closely with that organization. So you can see here some of the key tenets or key differentiators, if you will. It is a Ethernet-based fabric with MAX, but it's also highly integrated in terms of its control plane capabilities, along with the Slingshot NICs that you can deploy in HPC environments or Gen AI clusters. So best in class in terms of latency, being able to provide interoperability and ubiquity with Ethernet. In fact, one of my CX9300s acts as a gateway from a Slingshot cluster out to the traditional Ethernet backbone, if you will. And then, being able to provide all of the innovations from a software stack, so congestion control, adaptive routing capabilities, integrated security capabilities. So these are all some of the key IP that, again, we're contributing back to the UEC in a way to accelerate for the overall ecosystem and the market. And then with that said, the proof in the pudding is really the supercomputers. as of Monday, you could see here that we had the number 1 and 2 spot, but as Antonio had shared with all of us, the Lawrence Livermore, or El Capitan, is now the number 1 supercomputer. So HPE, along with Slingshot, holds the number 1, 2, and 3 spot for the largest supercomputers in the world that have also leveraged HPE Slingshot fabric technology. So this is a very well understood, hardened production fabric solution, again, much of which we're looking to contribute back into the community by way of the Ultra Ethernet Consortium. Okay, so now I'd like to shift gears here and touch on where HP Aruba is looking to build and innovate in this particular area. And we've been on this journey for a few years now as well. Much of the fundamentals start with introducing capabilities like data center bridging, Rocky V2 capabilities, congestion management capabilities, dynamic load balancing. Adaptive routing is more of a roadmap capability for CX. We're making enhancements in that CX software stack so that you can take advantage of adaptive routing. Again, the simple concept that you can take any number of spine links, spray packets, reorder them in a way that you can really minimize that latency, maximize performance and utilization such that your AI workloads, there's no compromise in terms of the GPU utilization. And so when you think about the different fabric types, these are 3 examples of fabrics that could be used certainly in that back-end fabric, but also in the Gen AI fabric in the middle, which historically has been, again, InfiniBand. And so the first one should be fairly familiar to all of you. It's a very traditional leaf and spine fabric environment, sometimes called a fat tree with non-blocking bisectional bandwidth. You have spine switches, leaf switches that are all interconnecting the pods and the compute. And really the cream of the crop, the highest performance, is what's called the rail optimized fabric. And here, as I was mentioning earlier, if you can see at the very lower level, you effectively have in each box a compute node with integrated GPUs. And there's a fabric within there. And that fabric, again, as an example, could be NVIDIA's NVLink. It's a PCI-based fabric, but it allows for the GPUs and CPUs to have a communication path. It's a very high-performance communication path. And then you have a second parallel path. If you look at the rail switches on top, that interconnects those host nodes. And so again, you have a parallel path that allow the GPUs and CPUs to communicate across the compute and GPUs, and then ultimately the spine nodes that will allow you to interconnect the rows and the racks together. And so this is, again, what's often called the rail optimized architecture. And then a more simpler version of that is the rail only, where you have the interconnects within the high performance devices and then a spine layer on top of that. Hopefully that makes sense. And so the key building blocks from HP Aruba is we have two solutions today. One is called the 8325, 32 ports of 100 gig. So this is ideal for a rail only, that simplified version, lower performance at 100 gig. But when you are looking for that rail optimized solution for both the leaf and spine, we do have what's called the 9300 that provides 32 ports of 400 gig. Right? And so as I mentioned earlier, the next generation to that coming out next year will be a 64 by 800 gig, so you'll scale up as well as scale out in the event that you have a much higher performance rail optimized fabric environment. Right. So the next couple slides kind of gives you a view of how can you scale a rail only solution. So depending on the connection speed, whether it be 100 gig versus 400 gig connections, you have the ability to scale up to a number of GPUs, 256 upwards of 1,000 GPUs, depending on the number of GPUs per servers that you have. This is, again, more of a reference slide. And then you can see a similar use case if that you had 400 gig per port connection. This will allow you to provide additional scale. Depending on the number of leafs you have and the number of GPUs, you can provide much higher performance with a high radix number of ports. Okay, so I wanted to close here with a demo. This is some new work that the team has been doing. Perhaps some of you are familiar with Central. So in our next release, the team has been working on, the next release is due out in the next month, so let's say 4 to 5 weeks. We have a solution, and this will give you just an architectural view of the demo that I'm going to share with you here shortly. But we built out a rail-optimized back-end fabric, 400 gig, leaf and spine. It has employed RoCE v2 for a lossless fabric. We are using Ixia solutions to simulate a 16 GPU network environment, stateless dynamic load balancing, RoCE v2 simulation, as well as AI and ML traffic simulation. So this is all new software that's being developed. And the general background is that we're leveraging Central to provide visibility across your Gen AI cluster, and ultimately to provide insights where a particular workload may be experiencing latency, and then ultimately make a config recommendation. So leveraging AI ops for configuration, and ultimately to be able to pinpoint where that latency may be experiencing, and then recommending a config update to make an improvement. So that's kind of the general backdrop. Let me go ahead and jump to the next slide here. So you can see here, the demo is identifying that there's one application, a number of devices, and it's identified there's congestion in this particular environment. And so the whole idea is that you want to be able to say, okay, I want to go to a config recommendation, and then you'll go to the topology view, and you can see here there are 4 leaf switches that are impacted. And so ultimately what you want to do is filter on those leaf switches to identify where the congestion is. Now with that said, we're going to look at the application view. And you open that, you can see that there's the 16 GPU clusters where there's very high path latency. You can see that the reason for the challenge is there's high path latency. And then from there, ultimately, we want to get to a view path trace to really identify and isolate where the latency is coming about. And so here you can see a node view, and here it's actually leaf 4 that's experiencing the issue. And so this is all, again, AI technology in the background that's helping isolate, where the particular application is experiencing latency, and then using the technology to isolate, down to the particular node, the application where the issue is. Now, with that said, the idea is that, can we recommend a new configuration? So we'll come here, go to configuration. The idea is you want to select AI ML, and then you'll make a configuration update. And so as you make a configuration update, you'll also be able to preview what that config update is. And then when you set it up, you'll want to configure it for ECN, PFC, as well as dynamic load balancing. And then as you make these config changes, you may trust, but we'll certainly look to verify, so you have the ability to verify those config changes before you commit them. And so now the whole idea is that you should be able to go back and look at the performance of the environment, and lo and behold, you'll find there's no more latency or high latency in the paths. So that's a very quick demo. It's a very simple concept of how you can leverage AI technology in a tool like Central to bring about isolation, visibility into the environment, but more so to recommend a config update. Okay, so one of the last couple slides I wanted to bring up is I mentioned HP building out a Gen AI solution. This is a chatbot. You can see Antonio Neri. It's some semblance of him. There's an avatar. You can see here in the lower left is the infrastructure that includes 2 CX9300 switches, a number of DL385 servers with GPUs integrated in that. So there's a full hardware stack. Along with that, there's a software stack with vector database and a large language model provided by NVIDIA. And then there's guardrails, processes that we've integrated. And so this is a fun avatar. It's a chatbot. I don't know if it's actually here today. It is. Okay, so go down and see it in the discovery zone. I remember some of the team members were asking, like, am I going to get a raise today, this year? And he's actually quite eloquent about how he responds without completely shutting you down. Anyways, it's just another fun experience of how you can leverage the technology. With that said, I just wanted to close with the idea of what are the benefits of an HP Gen AI solution. Certainly it's the opportunity to build out that infrastructure. It can be done, on-premise, near-prem, hosted, in your environment. But also thinking about how you can deliver that performance based on an Ethernet standard solution, without the cost of InfiniBand, if you will. But also think about the governance, the sovereignty and control around your AI solution. So whether it be with HP Professional Services or thinking about this yourself, ensuring that you have a robust and ethical, secure solution that's also very human-based. This is very part and parcel to how you should think about the Gen AI solution that can support training and inference. There is another slide here that just provides you a number of references for your information, so you can have them at your access. And so with that, if you have been an Airhead, I thank you. If you're interested in being an Airhead, there's a link here to join as an Airhead. We are a very large community. I think it's 300,000 large at this point. And so it's a very large community that help each other around design, support, different issues. And so you're encouraged to join our community. With that, thank you very much.